To be part of this expert talk series. My name is Gigi Ghanim. I'm the Chief of Staff at data.org, where I also lead our government engagement work. I'm glad to have my colleague with me here today, Avinash Laddha, our Senior Data Analyst as well. Our objective today is to share how data.org accelerates impact through our global network by building both data and AI capacity. And also, we wanted to provide some free and practical resources to support your own work. My colleague Avinash will then showcase some of our technical work through our partnership with the World Health Organization to showcase a tangible example of how integrating AI powered search functionality can help epidemiologists find the tools they need faster so that they can make more informed decisions in real time. So, for a little background on data.org, we serve as a platform for partnerships to accelerate the use of data and AI for social impact. We bring together diverse stakeholders across sectors to bridge the data and AI innovation gap in the social sector. And we are on a lofty mission to train 1 million purpose driven data practitioners by 2032. Our work is driven by three strategic pillars that include identifying and amplifying groundbreaking data and AI use cases in the social impact sector. Two, empowering both people and organizations through capacity building by developing talent that have both the technical skills and the ethical frameworks to make the biggest impact. And three, supporting the digital commons by co-developing and sharing digital public goods and resources to the wider community. In just 5 years, we've trained over 100,000 purpose driven data practitioners and equipped social impact organizations with the tools, assessments, and resources to enhance their data maturity. We know that AI is transforming how we address social challenges. So that's why we focused two of our global challenges, the Generative AI Skills Challenge and the AI Acceleration Challenge, on amplifying organizations that are effectively using AI to drive social impact. Our Capacity Accelerator Network develops purpose driven data talent with the interdisciplinary practical skills to solve real world problems. With hubs around the globe, we are able to scale our work by sharing all the co-developed tools, the curriculums, the content across our partner network so that they can adapt them and use them in their own context. Collaboration is the key to our impact. By connecting philanthropy, technology companies, academic networks, social impact organizations, and government agencies, we create powerful partnerships that can accelerate solutions at a scale that is really difficult to achieve alone. So please feel free to reach out to us after this presentation to explore how our resources, network, and partnerships might be able to help advance your mission. Through our government partnerships, we're scaling data and AI literacy at scale by adapting to every country's unique digital infrastructure and aligning with their policy priorities. So in India, we leverage their own national learning management system to host our responsible data management course, a model that works really well with countries that have existing government learning platforms for their civil servants. In Nigeria, where there is a strong mandate towards digital transformation, our course aligned quite well with their efforts to build workforce capacity as part of their digital economic priorities. Most recently, we are really excited to have a signed partnership with Thailand's government agencies to support AI literacy and data skills training for university students and civil servants, which is all just illustrating how collaborative partnerships can effectively accelerate digital readiness and capacity in the public sector. We've developed offerings to help strengthen data capabilities through courses, training, and resources with various topics and themes that can align with your work. So, for example, we have several resources developed with a gender lens. These include a gender data and climate playbook. That includes practical guidance on integrating gender considerations into climate data work. We also have a Gender Data 101 course that is a beginning level one that I wanted to take myself. And we've compiled use cases featuring gender focused impact stories. For those that work in government with an interest in AI, one of our most recent publications is our generative AI playbook for civil servants that was created as part of our work with Microsoft Philanthropies. This playbook was designed to provide baseline AI fundamentals for non-technical users. It showcases real-world examples of government AI use cases and provides an overview of popular generative AI tools to try and guidance around ethical use. And this is a great resource, even if you don't work in government as well. All of these resources are free and available on data.org's resource library, where you can also find additional tools like our data maturity assessment that can provide you with a custom tailored guide um, journey to support your data and AI journey. At data.org, we're not just supporting innovative AI applications, we are also actively collaborating on strategic AI initiatives as well. So if you look at our global challenges, we are seeing awardees using diverse AI applications tailored to local needs. In India, the Meena Mahila Foundation is using AI-powered chatbots to provide women's health information in multiple languages. While in the US, we have an awardee, Link Health, that created an AI enrollment platform that has been able to unlock over 10 million US dollars in benefits for low-income Americans. So this just showcases how these solutions um, can have AI address critical needs in communities often overlooked by technology. We've also partnered with the Data Science Nigeria. I'll let you go back because I wanted to speak on a few of these. They and others to build an open access playbook for digitizing low resource African languages. And this work will address a critical gap where many African languages lack the digital infrastructure that is the precursor for AI development. And we've even integrated AI search functionality on our own website to allow our users to get the type of search results that are most pertinent to their search query and truly help them in their data journey. So please go to our website. You can create a free login, use our guide finder, and see what resources come up as recommended for you. And finally, data.org is working with the World Health Organization's collaboratory to develop AI-powered tool discovery for global health researchers. Using natural language processing, we're creating an intelligent search functionality that helps epidemiologists find relevant tools quickly to empower them to make more informed decisions way faster. So I'll turn it over to my colleague Avinash Laddha, who will walk through how the search tool works in practice in the real world to reduce duplication foster collaboration, and increase the visibility of existing tools for public health officials, epidemiologists, researchers, and the broader global health community. I'll hand it to Avinash.
Thanks, Gigi. I've quickly put a small question which is relevant to this particular talk in the chat. I'm Avinash. Thank you everyone for joining the session today. Me and Gigi are delighted to be a part of this session. And Gigi is joining, as you all know, from all the way from Philadelphia, which is almost midnight for her. So Gigi really appreciate it. I owe you a nice strong espresso when we meet next. Today, we'll explore how machine learn to understand language, like the words we speak, and how that helps in solving real-world problems, especially through something that has evolved over time and which is called semantic search. This is different from, not different, but aligned with search, but it has the context. So when you want to search a word, for example, I have a broken cycle, which is similar to I have a flat tire in my bicycle. What we expect is to have similar kind of responses or similar web pages that can help us. And this is where semantic search comes in. So before we dive in, if everyone can take a look at the question that I've posted, and it is just a yes or no question, most likely it is yes. And that is the kind of problem we are trying to solve with this model that we are building. Okay, I see a couple of responses. All of them are yes, so that is good to see. So the question is around, think of a time when you search for something online or in an app or in a folder on your computer and the results weren't what you were expecting. So the search doesn't get you in a way. And a good number of you have responded yes. So this talk today would be relevant. How we make computers think or not think, but return the responses that we are expecting it to return when we search for a query. This particular project, the need came around with some of my team members, especially Hugo and Chris, who went to conferences and realized that there is some level of mismatch in the way people are looking at packages, what to build, what is missing. So in the conferences, they realized with interaction that people are saying, okay, it would have been really nice if we had this package to do X. And then Hugo realized in our Epiverse initiative itself, there is a package which does exactly that. So how do we highlight it? How do we make it more visible? That could be done using having an improved search functionality on top of packages. One of the limitation that we have with why that was not visible is because Google does not index the package documentation or the code documentation as well as it indexes the web pages. So that was one key area that was highlighted. Also, if you are a developer and you want to build something, you might end up having a duplication effort. Like I just posted a very relevant meme which talks about like duplication in a way. So on to the next slide, please. Search might seem simple in the first, but it can get surprising tricky, especially if you don't type the exact word which the system expects. And this happens quite a lot with technical documentation. So when you are searching, for example, help me plot infection spread, which is similar to help me visualize. So these might return different or no result if there is no underlying semantic search. So the idea with this project was to synthesize the current knowledge in a way it is easily searchable in natural language. If I am someone as a data analyst or someone getting started with analyzing data, I want to be able to type, okay, help me plot infection spread for this country, and I have this following data. It should be able to respond to me with the available packages. There might be some packages which are not there, which are yet to be built, but whatever is there, it should give me that list of packages. And so the core idea was to synthesize this current knowledge in a way it can be accessible. And then we built the search tool with WHO, which is nothing but a simple web-based tool that helps user discover epidemiology, related software, and resources around the globe. This also aligns really nicely with our data.org mission. We want to build a connected open source ecosystem for disease analysis and reduce duplication as much as possible. Now, I will quickly jump to how the current uh, dashboard looks like. The main reason I want to go top down is to build an understanding of how it looks like, what the end product is, and what goes behind this. If you take a look, there are three arrows on this one. Let me just find how I can annotate this. Just a second. Okay, I cannot find the annotation. So the first arrow on the left, it is the title of the package. The second arrow on the right are vignettes. Vignettes are nothing but the documentation. So when you search for a keyword called analysis, it returns these packages which are most relevant to the keyword that you type. You might as well type, I want to do an analysis to visualize XYZ, and it will return relevant result. On the third arrow, you will see there is this bar which is highlighted very less in the first one, more in the second one. This is nothing but how similar we believe these search results might be for you. This is a relevance score, which we'll talk about more in detail as we move forward. But this particular visual is included to give you an understanding of what goes inside data collection, as a majority of today's talk will also focus about what kind of data we collect. And to collect any data, we need to know what the requirements of the end product would look like. So we have three things. One is what the title is, description around it, the relevant documentations, and what your search or your model does to assign a score of relevance. Next slide, please. All right. If there are any question until now, please feel free to put them in chat. I would be able to look at them, or we'll have good Q&A towards the end, because I've kept it short to allow for more Q&A, because there are some abstract concepts with this. Now, this is the main thing of how search is being carried out across, be it Google search earlier, be it LLMs now. How do they make sense of what us human are putting in that particular search box? Because computer cannot make sense of the word where is Big Bang. For it, where is a numerical abstraction. So when you say where is Big Bang, it converts it into something called as a query embedding. Embedding are nothing but numerical representation of the phrases that you have put in. If you have put in, for example, the word analysis, as we saw in the last slide, it would have a different embedding. So you see this query embedding is then sent to the model that you have built, which is search model. This search model takes a look at whatever available text is there on your left, which is the archive. All the text that you have, it has also been converted into embedding. Embedding is again nothing but a numerical representation of the text that you have. Now, the work that the search does is match what this particular number or this metrics is most relevant with, which of these embedding line up the highest. And then after doing some calculation, it gives you the final result, like top 3, top 5, whatever you want. So the whole idea behind this is whatever number that you're putting or the phrase you're putting, it is converted into text. It is then sent to the model, which analyzes based on the data it is scraped. It may be wiki, it may be news article, and then give you what is the most relevant, mathematically relevant search result. One thing to also understand over here, it is all math. So when we talk about can LLMs think, this is one thing to ponder about. It is all numerical and mathematical when you go to the very basic level. On to the next slide, please. To ground the understanding better and build an intuition around embeddings, it is good to understand what embeddings are and how they have evolved over time. So I come from this west part of India, where we have multiple languages. You would even see the dialects changing every 50 kilometers or so. So when I was a child, I used to learn three languages. One is Hindi, Sanskrit, and English. Early on, when you are translating one language to another, when you are just getting started, it is very likely that you might want to do word to word swap, which works at a very simple level, but it breaks when you have complex sentences. So that is what got us started in NLP. In the starting, you would have seen anyone who is 90s kid who would have seen how translation has improved over time. If you would have used Google Translate in 2010s, it is drastically different from what it is now. Currently, it has some errors, but the way it used to function earlier was way different. There are two types of embeddings. Okay, if we can come to the next one, I want to take embeddings in a separate one. Next slide, please. Okay, so now we'll talk about how embeddings or conversion of text into numbers have developed over time. So if you are a researcher in 2000s or early, what you want to understand is you have this text and you want to analyze how important the words are. Given that there are limitation of computation, what you do is then you try to weigh how important a word could be. And the way a word importance could be assigned is how frequently it is occurring. So if you have a document, if it is about education, education of women across Southeast Asia, for example, you can say education is an important word if it is occurring frequently. Now expand that one document across a million documents across the internet. What we want to see is how it is occurring across other documents as well. And this is where TF-IDF comes. It is term frequency of that particular word in the document multiplied by how frequently that particular word is occurring throughout the corpus that you have. So these were very initial days where we had statistical approaches of analyzing text. Until now, we didn't know what the context of the word is. For example, if the word was bank, at TF-IDF level, we couldn't differentiate whether this bank means the money bank or does it mean the river side. So those were the limitation. And the next improvement that came around was during 2030, 13, 1 3. The last slide, please. So 2013, we come to prediction-based model. Now the machine learning models have improved. We have good compute power. What we want to now understand is, if I have a set of words, what would be the next most likely word that would occur? I want to go out and a good prediction of the word that comes next could be eat. I want to go out and eat, or it could be play. I want to go out and play. This would be dependent upon the corpus that you have. For example, a large number of these models were trained on Wikipedia. So it defined what is the most probable next word. This is again another sort of intuition that your LLMs are dependent or they learn from the text that you give. And therein comes in another implication. If your text is biased, and this has been a talk around the whole LLM community, is there are biases creeping up. And if you follow the latest news, this has been highlighted with the Grok latest model from Twitter as well. So this is one thing to understand. These models are built on the text that you provide them. So we are covered two levels of embeddings. Embeddings again are nothing but numerical representation. It gets complex over time, but the base remains same. It is a numerical representation. So what we realize with the prediction based words is we are able to predict the next word, but it does not again get the context where the word is said. So then we developed context based embeddings where the embeddings were not static but dynamic based on the particular statement or the phrase. It used to have that particular embedding. For example, again, if a bank is a money bank, it would have different embedding as compared to the Riverside Bank. which were similar in the previous two generation. And this has brought about the whole different level of understanding and level of functionality that LLMs are able to do now. On to the next slide, please. So now this is one level deeper, and this should really drive it home of how embeddings are being thought about and what is an intuitive way you can understand these embeddings. For example, we have a list of words. Let's say those are these 8 on the left. What we now want to do, we have some parameters. Let's call it on the top, you will see living being, feline, human, gender, royalty, verb, or plural. So these, when you convert cat into an embedding, this is how it looks like on a very meta level. With feline, it is 0.9. But when you compare this particular parameter with men, it is minus 0.2. So it says that it is not aligned with this particular category. It is -2. When you do the same for human, the cat is 0.1, kitten is minus 0.1, but this value is really high for men. On the bottom, on the men, women, king, and queen, saying that this particular parameter, it is very highly aligned with these words as is seen in the corpus. So this helps you understand, okay, there are some parameters. Currently, these are 7, but in actuality, it could be 500, 700, up to 2000. And they are non-intuitive in a way. They are not like living being, feline, or human. They are just part of a big matrix. But it looks something like this, where you have a word and you convert it into a mapping, which is numerical, which helps you identify what that word is and how does it sit across the universe of words that you have. Next slide, please. I've put this slide again to drive home the intuition. Does it now start become familiar? So when you have a search query, where is Big Ben? What does query embedding do? They break it down. Where is Big Ben? Combine them and then send it to search, where it has the stored embeddings. And now what it does, it has a model which tries to align and find what is the closest embedding I can find against where is Big Ben. And then it returns you the results. So this is the whole intuition about embeddings and search engines and LLMs. Next slide. All right. If you have any question until now, I'm happy to answer them. Otherwise, I can take more Q&A towards the end. Now is the main part, the meat of this presentation, which is around data collection. As we saw in the very starting, how the current search looks like, there are a couple of things which were very important to us. What is the title? What is the description? What are the relevant packages? And what is the relevant score? To identify the data requirements, we have the data requirements now. We want to tell it what the package is about, how it works, where user can find more information. Second level to data requirement is also data availability. Is the data available for download? And this had good implication on the way we were looking at this search, semantic search model with WHO. We realized that with R, the documentation is really good, really wide, and we are able to get the data through packages. But the same does not exist for Python yet. So when you are you are building specs of the project, it is good to understand what you want and if there is a good gap, or you can get all the data. There are also some ethical consideration that we kept in mind during data scraping. We used the appropriate licenses. If it is not something that the website want us to scrape, we didn't use that. And this is also something you will see a lot of big media houses are suing OpenAI and LLMs for scraping their websites unethically. So that is also one of the ethical ways, ethical viewpoint that you can take care of when you are doing the data collection. So this is level 1. You have the data requirements, what you want to include, and what you can include given the data that you have. Now you come to the second level, which is writing the web scraper. and automating using cron jobs. This is specific for this particular project. Web scraper is nothing but it is an automated web browser, you can say. It opens that website, sees the text that you want, copies it to a file, and stores it. So we did same using a R package, the details of which I will share after this meeting with you in a detailed document. It would have these links where you can go and see how the scrapers work. It stores the data and it reads the data and stores it in a file format which we can read. Again, it has those four things. What is the title? What are the vignettes or the documentation relating to it? And the relevant description. All of it is now stored in a particular file. The next thing that we need to do is now how do we convert that text to embeddings? If you remember the last slide, the query slide, the search slide that we just discussed, on the left was an archive where the text was converted into embedding. And this is exactly what we're going to do in point number 3, where we choose a model to generate the embeddings and build an embedding store. Embedding store is just a fancy word for a collection of embedding. So you have this text, you have converted them to numbers, and now you are storing them for safekeeping in a store. On to the next slide. This is something that I use ChatGPT to give a very small summary around what you can use, what model you can use to generate the embeddings. Now, as LLMs are developing, what we are realizing that some models are good with Q&A, some are good with generation, some are yet another level good at extracting information. So depending upon the kind of task at hand, you might want to choose a particular model for creating those embedding. For some semantic search, you might use mini LM or text embedding ADA 002 as suggested. Or if it's code embeddings, the code search star. There are a lot of them on the Hugging Face library. You can try them out and see how your performance look like. But this is one big decision that you have to make when you are going to convert the text into numerical format. Next slide, please. And that brings us to the last part. Once you have all of these in place, the center search box that you see, now it receives the API request, which is nothing but the text that you have sent. It sends it over to the API or to the search box, where search box looks at the data or the query or the text that is stored against the query that you have sent. And then it returns you the most relevant packages based on whatever rules that you have configured. For Epiverse search, we did it at 2 levels. So one is whatever search is coming in, we want to first identify what are the most nearest neighbor of this particular query. So this is something called as KNN, K nearest neighbor. We want to first highlight the top 30 or 40 embeddings which are nearest. And then on level 2, we want to compute how close they are. This is done at 2 levels to make sure that we are not computing that particular calculation for like more than 50,000 documents, but doing it for top 30. That highly reduces the number of response time that is required. So to give you an overview of how Epiverse search looks like, we first identify what we require. We require a search which can return the title, a description, relevant packages, what is the uh, how relevant it would be for me. What is the relevant scope? Once you have identified the scope, you go about looking at data, what data is available. So this completes part 1. Part 2 is writing the relevant scraper and automating the job so that you can automatically get the data and store it, keep it stored at some place. Third is using a embedding model to convert whatever data that you have stored into numerical numbers. And fourth is then configuring a search engine, which is built of something that can receive an API request, a model which converts your text into embeddings, and then return the response with the top 5 or top 6 search result that you want. I believe this brings us to the end, and yeah, open to Q&A.
Thank you so much, Avinash. Thank you again, Gigi. I think it's been a very, very, very interesting presentation. And also, thank you so much for explaining complex concept in such a clear and understandable way and logic way as well. There is a question from Sidra Umayun that asks, can we connect it with the RAM? Are you talking about, Sidra, maybe you want to open the mic and explain
Yeah,
that?
thank you
Okay.
so much. I hope I'm audible. Yeah, I just wanted to know that UN Women have uh, gender scorecards, right? And I was thinking that if internally we can, is there any way that whatever the data we collect from different UN agencies can be connected to this, and RAM question also is there, that that assessment, readiness assessment methodology can be connected if this data can be helpful in that. Is it possible? Thank you.
Thank you so much, Sidra. To add more context, RAM is an acronym that stands for Readiness Assessment Methodology, and it's an analysis tool developed by UNESCO in 2021 to also, for those who weren't able to attend the last expert talk, to analyze a country's readiness level to introduce AI and new and emerging technologies into the country from a policy, law, but also education point of view. So assessing how much the population is ready, how much the policy and normative environment is ready, how much the industry environment is ready, and so on and so forth. It is one of the tools used by the UN to assess and guide countries in how to implement AI ethically.
All right. If I understand it correctly, this the tool that you have, RAM, it would have two type of question. One is very objective, you can choose it, and second is you can give a response in text to that particular question. Is that a correct assumption?
Yeah, but I think what you understood, I could like to listen more on it, because it has a context of UN developed tool. So that's why maybe that knowledge is limited to AI school so far. So I cannot expect that you can answer. So feel free, whatever you can answer into this. Thank you.
All right. So for any kind of semantic search to work, we need some underlying text. In case your tool is capturing this textual data, for example, when you say you have a gender scorecard, it is based on some sort of qualitative and quantitative metric. If you have some text that you want to analyze across the responses that you have taken to this tool, what you could do is then highlight some words which you have found very useful. For example, if it is girl child education, you might want to assign it a higher score. What you can then do, process all the text, give particular weightage to these words, and which can then and give you a final score. This could be one of the metrics that you can use when you are assigning the gender scorecard towards the end. Uh, does that answer your question? So, can you hear us? Is there anything specific that you want me to highlight? Because we also have a tool, and the version 2 of DMA, AIDM is also coming up. I think Gigi would be able to talk more about that. That would be highly relevant to this use case.
Yeah, absolutely. We have a data maturity assessment that anybody can try out and use to identify the level of data, and hopefully soon we'll have an AI component to it to gauge the level of data and AI readiness that someone may have. And then based on that score, a number of resources will come up tailor-made for you on where you can help fill in those gaps and improve data maturity. It is also on our website. If you go to data.org under the library section, you'll see DMA or data maturity assessment to try out. If you create a login, it would be able to save where you are, and then you can try to take it again and see the level of improvement from there as well.
Thank you so much. Sorry, I jumped out of the call for a second. The office has a second on the blackout, so I hope the question was answered. Any other question for Avinash or Gigi?
Any other question regarding a knowledge base that you might have that you want to democratize? For example, there are 10,000 of documents that you have, and it is difficult to search what relevant information you can find. This approach could be one way you can do that, where you identify the keywords, what is most relevant, and on top of that, like build this search. So any questions around that, happy to answer them now, or I'll share a document and you can reach to me over LinkedIn to understand more at code level what we built. And the GitHub repos are open source, so you can take a look, raise a request, feature request, or contribute to it as well.
Thank you so much. Maybe while participants think about, I think they have also like absorbing the concepts. So while the questions gone, I wanted to ask, participants will have a grand challenge in which they will have, as a part of the AI course, at least those who attend, we have 2 tracks. One of the tracks is called the public cohort, is the one that goes a bit deeper. And they will be asked to develop a solution that somehow, or an idea for a solution that tackles contemporary challenges. One of these solutions could be a custom GPT, or in general, a custom AI assistant, leveraging an existing LLM like Gemini or ChatGPT, DeepSeek, etc., etc. So, of course, we know that custom GPT can also, it's already filtering somehow the information based on our request in the knowledge base. But is there a way that we can also refine the research there, weighting some sources more than others? And what would you suggest in general when building a custom GPT in this sense? So not something from the ground up, but something as a filter on an existing LLM. Thank you.
All right, so there are currently 2 ways. The RAG, there's this approach called RAG, re-augmented GPTs. So which is something, you have a LLM on the basic, on the very base that you want to use. On top of that, you want to provide it additional context. For example, you have OpenAI API that you want to send the data. At the same time, you don't want to send all the data. So what happens is you can configure the rules using RAG to say that, okay, for me, girl education, this keyword weighs 2x as compared to just education. So you can configure a RAG on top of the model that you have and build a fine-tuned model. Now, another approach is prompt engineering. So this has come as an effective way, another effective way that you can use. You configure the prompt in a JSON file saying that this is what the context is, this is what is expected, and then you do some level of hit and trial and see if it is giving you the required responses. One thing to keep in mind is these prompt engineering are heavily dependent upon the version you are using for the GPT. Same prompt might result in slightly different results on different GPTs. So these could be 2 approaches where you configure a RAG saying that, okay, this is what I'm looking for, these are specifications, and then you build on top of existing one.
And I could add a little bit around the prompt engineering part for non-technical users like myself. Accuracy is always an issue, and sometimes it's unavoidable. So it's really important to review your outputs at all times to make sure it's accurate. And the more you invest in the prompt on the front end, the more likely you'll be happy with your results later. So the way I frame it to help me with it is to really think of building a prompt with a role, give it a specific task, and then use clarifiers to really hone in on what you're looking for. So for example, if you're, I'm thinking more like administrative work, like if you're a communication specialist and you're publishing a newsletter on a report that's coming out, you would say, you are a communication specialist, so that's the role. Transform this report into a newsletter-friendly article. That's the task. And then use simple language and include practical examples and structure it with clear headings and keep it under 400 words. These are the examples of the clarifiers. And I think that really will help in just better quality outputs.
Thank you so much, Gigi and Avinash, and also for the participants. As you can see, elements like RAG or retrieval augmented generation comes back. So for those of you who missed last lesson, please review the video from the lesson because RAG is there, and take the quizzes, etc., as well as from prompt engineering, as Gigi was saying. Please make sure to review the videos from prompt engineering lessons as well, because everything builds up on what we talk about in the previous lesson. And as you can see, there are things and topics and concepts that come back more and more. So is there any other question, maybe also on the ethical dimension of data that we mentioned many times? Like, this is a very nice opportunity right now to grab all the information you need, especially from a practical point of view, to also, think about the grand challenge that you're gonna the project you're going to present for the Grand Challenge, and it's also a time in which you can leverage the help of very, very amazing experts here. So please feel free, don't be shy, also in the Q&A panel. And while these happen, and if there is anyone, please raise your hand and even open your mic. Maybe a question that goes a bit back in terms of the lesson that we had today is, as a data scientist for Avinash, but also for Gigi, etc., data.org stresses the importance of data. You mentioned ethical problems and ethical elements to take into consideration as well. So, of course, I think we should need another lesson to explore these questions in depth. But maybe what are the golden rules or some rule of thumbs that you would like to share with participants when it comes to feeding data to a model, or to even build an SLM, or let's say an SLM in this case? So some rule of thumbs that we should always take into consideration.
Okay, the foremost rule with any model is, and especially for LLM, is garbage in, garbage out. So you want to make sure the data that you're feeding is aligned to the kind of responses that you want. With us, one of the key highlights that I mentioned was the data availability as well. Such kind of documentation is done in R by the researchers, but not the same is done in Python. So one is garbage in, garbage out. Second is whatever our end outcome is, keep the end in mind. So if you want description of the package, make sure that data is available. And third is pre-processing. Pre-processing goes a long way. LLMs are able to understand the text, the context, but not if it is like too big a document, it is difficult for it to understand. So there are a couple of pre-processing techniques where you might want to use, for example, chunking of documents. LLMs have a defined context window. If you feed it like 10,000 lines, it might not give you the best result. But if you break this 10,000 lines into maybe 50 lines or 50 sentences each, build an embedding on top of that, and then do it, it would result in far better results. So these three things: garbage in, garbage out. Second is make sure you have the data that you're looking for, the kind of responses that you want. And third is pre-processing goes a long way.
I
So
would
that
add, oh, sorry, continue.
Go ahead, Gigi. We'll take the question after that.
Oh, yeah, I was just going to add that in some lines of work, confidentiality is really important when it comes to use of public AI tools, and just being very mindful about sharing sensitive data. So trying to stay away from personal data or confidential reports or classified information. Anything that can identify individuals is definitely a best practice. What is safe to use often is publicly available information, drafting, correspondences on non-sensitive topics, summarizing articles and reports. Brainstorming with open data sets is one that I'm really get excited about. And, also asking the AI to suggest ways to improve upon your work in ways that mentions those guardrails around confidentiality. It's different when you are working with an in-house custom language model, or if you have contracted with a third-party language model provider. But just with public used AI tools, it's just a rule of thumb to around confidentiality is a good lesson.
Thank you so much both for highlighting very important topics. I see Sidra with her hand on. So Sidra, do you want to open the mic and
Yeah, thank you so much, Avinash and Gigi, for answering my question. I was disconnected for a while. I have a follow-up question that if we have developed some indicators, and those indicators can be adjusted or added in the software maybe that data.org has, and would it be able to comprise or prepare any report against it, or do we have to go more specific way to generalize or articulate some report on it? Thank you.
If I understand the question correctly, you're asking if the tool that we have, does it give you the indicators that you need, or do you need to configure it in a way? Is that correct?
Yes, yes.
Okay, so first clarification is currently this tool is hosted on WHO Collaboratory on their internal documents and this documentation. It is not available on data.org main site as of yet. But to answer your question, if you want to prepare a report, the approach would be similar, but there would be some pre-processing steps that you need to take care of. And in the end, apply some weightage based on the expertise, the subject matter expertise that you have far better than any LLM would have. For example, taking the same example back again, if you have this text or maybe some proposals which highlight education, you might want to give extra weightage to inclusive terms or their past work, inclusion of like quantitative numbers to highlight the impact and things like that. So all of these combined, along with the model that you have, it should be able to give you the reporting numbers as you expect.
Thank you so much. I see there is another hand raised from Rishwa.
Hi, Avinash and Gigi. Thank you so much. This has been super, super interesting. So I'm just trying to understand it better. So you mentioned a couple of resources available on the data.org website, but I'm trying to understand is, so are they like these softwares which we can then use with all, codes which we can then use with R and other models, or what exactly are they, or am I going to use them to create some sort of custom GPTs? Like, maybe you answered this, but I'm just really not clear. How can I use it?
Oh, yeah. So what we have is more educational resources for basic and intermediary level around data, especially in specific areas, specific domains, like the intersection of climate and health, areas of financial inclusion. So it's really looking at how we can use data to promote areas in social impact, as opposed to more technical coding or that kind of thing. We do have a lot of our packages that are specifically tailored to our health work in epidemiology that is publicly available. And that is all open source. But that's a very, very niche area in public health.
Thank you so
To
much. Oh,
with
yes.
you slight more details on this. Currently, the way it is not as a SaaS. We have built it as ad hoc solution. What we want to next do is you upload a bunch of documents and it gives you search on top of that. Currently, it is code that we have developed, and it only returns the text, relevant text, which has already been feeded. So it is not GPT which you can question answer with like off the shelf. but it requires some configuration. If you have the text, you can just copy the GitHub code that we have, run the embeddings, and it should be able to give you the kind of search result that you want.
Perfect. Thank you so much. And of course, we will, I asked already Avinash, we will share the links and all the information after the lesson so participants can give it a look even more. And yes, I think there's a lot of resources that people here will be interested in exploring, especially because 1 hour of AI school or presentation sometimes is not enough per week to cover all the topics and, all the specific interests that people may have in one field or another that can be related to AI. Is there any other question for our speakers? Otherwise, we can start closing also for Gigi, who is basically working at midnight for us. And I would never stress this enough because it also shows the amazing commitment and support that she's providing us with. So if there,
may I?
Yeah, sure.
Dr. Lipika, yeah. And thanks, Gigi and Avinash, for a wonderful session. And hello, everyone. A very quick one. So I've been using ChatGPT very recently. I'm a lawyer, so I'm not very a technical person. So my very basic question, it gives you a lot of lies. Despite giving clear instruction, this is the data I'm providing. This is the thing. Please write this very specific. And I have started giving instruction. Please don't contact facts. Don't give fake information. Despite that, it keeps giving. Out of 25 times, 3 times I do get and I go back and tell this is wrong, don't do it. It will say sorry and again repeat. Where I'm faltering, please. Thank you.
So you are not faltering anywhere. This is one of the limitations that we currently have. There are two things that I have used in my usage. So one is you in the prompt that you give, you say that you want references, whatever online references or documentation that the model is referred to be included in the response that is there. So it will always require one level of human intervention or review of the answer that GPT is giving out. Second thing that you can do is effective prompt engineering. I can share some resources in a way you can have a prompt file, not the text, but its own file, which is something that these GPTs understand a little better as compared to text. You configure that, and you just, whenever you are uploading your question, you just copy paste that file to ChatGPT. This will serve as the context and the prompt, and it seems to work better as compared to simple prompt written in text. But it would never be 100% accurate. This is something that I've seen myself, and yeah, human intervention is required.
Thanks so much. That makes a lot of sense, and I'll be grateful if you could share that prompt thing. Thank you so much.
I would also add that it might be a good idea to try other LLMs as well. That's what I do when I find that sometimes one is working finicky and not giving me the output that I need. And I want to double down on asking it to cite the sources when you ask for certain outputs too, just to feel good about the outputs.
Right. Thank you so much for that guidance. And I really appreciate waking up mid of the night. Thank you so much. God bless.
No problem. It's a pleasure to be here.
Thank you. And yes, Avinash, yes, if you please share, we will share with our high school members as well. Please, Dr. Lipika, feel also free to review the lesson we had on prompt engineering. And we also uploaded a guideline in the reading materials, which can also be integrated with that, as well as maybe the lesson. Sorry, my Italian accent is kicking in at the end of this session. I was like, the lesson on custom GPTs and how to build, library, especially when we work for the UN, because it filters a bit, at least together with some prompt engineering techniques. It can be helpful to get the answers you want, as well as to reduce hallucination together with drag, etc. So the last 3 or 4 foundational classes of the high school can also be very helpful to, recap how to reduce hallucinations. And of course,
thanks for that guidance. We'll do that. Thank you.
Thank you. If there is no other question, I would first of all thank again both Avinash and Gigi for being here today, for their amazing presentation, very clear. On behalf of you women, we're very happy to have you. We think this will be the first step into a longer term collaboration, and we're very happy to have had this lesson. And see, we will share all the resources you give us with participants together with the recording. And then, of course, Avinash shared his address in the chat. We can share also some contacts upon your request. So we can still keep in contact and build a community of practice that leverages AI in an ethical way, every one of us in their own specific field. Thank you so much again, and see you soon.
Thank you all. Take care.
Bye. Thank you so much.
Thank you.
Thank you.